For those of you who are trickling in, I'm going to go ahead and start talking about a few things for people, and I'll give it a few minutes though before I really get going, just to make sure people are coming in. So this contributor playground experiment hopefully shows folks a few things. As we look at the commits that people have made, about half of the commits have this CNCF CLA no label. And that means one of two things. Either you haven't signed the CLA, or you have, but your Git config has an email that's not matching what you signed the CLA with. So I think for everyone who had this label, I copy-pasted a link that has a specific set of instructions on how to update and amend your current commit and PR once you've signed the CLA. So you'll have to sign the CLA and then fix up your commit. And then the bot should automatically notice and amend that label. The other thing that this workflow demonstrates is, so quite a few people notice, hey, the README says Seattle instead of Barcelona. So I'll change Seattle to Barcelona. But 3 PRs doing the same thing, we can only merge one of them, right? So you get conflicts, or maybe if somebody adds some little bit of text and somebody else added something else, things will start conflicting. And to get your PR to merge, you may have to rebase and or amend your PR. And these are just simple day-to-day sorts of Git workflow things that you will go through. So if you struggle with that here, it's a sign that you might want to go try and find a little more information and practice the Git rebase workflow. And it's something on a large collaborative project that will come up regularly. You're changing a piece of code, but somebody else changes something right next to it, and the way that they interleave, whoever comes along second will need to update their commit so that it's able to merge. So hopefully folks are working through that, and we've got our committers going around LGTMing and approving, and people are working through their CNCF CLA signing issues. And we'll kind of touch back later in the day on this. And also, this is like a live GitHub repo. So there's people elsewhere in the project who care about new contributors also and who are watching. And we'll try to usher things along a little bit. And hopefully each of you can get some sort of initial little thing that you trialed here just to show that that stuff was working for you. Does anybody have any questions on that? No?
What kind of changes we can make? I mean, there's only 2 files.
Well, there's more than 2 files, I think, now. Somebody's introduced a new file. Somebody has added a link to some extra documentation or things like that. So if you're a new contributor in this workshop who's looking at this file, maybe you add a little bit of extra information. Somebody who added a little piece of extra something intentionally added a spelling mistake, so somebody else could come in and fix the spelling mistake. So it's just all sort of playing around in that regard, just to get a little bit of basic practice. So just to reiterate what we did, we forked and cloned the repository, we were making changes in that Barcelona directory, then we tried pull requests, and then we ran into some examples of that open source collaboration, reviewing, commenting, rebasing, and interacting with labels and bot prompts. So we tried to make this a little example playground that would, in a couple of short minutes, mimic some of the types of interaction you'll have on Kubernetes-related projects, or more broadly, open source. So, moving on, I want to do a brief development environment check. So our goal was to see, were you able to run the make command? Who has successfully run the make command? Pardon? No, just ran make and didn't have an error. I mean, it may have sat running for a while. Who has gotten to the point of trying to run make but has not succeeded? So does that mean everybody's not tried to run make yet? So who has not yet tried to run make? Let's do that one. Okay, so we're going to spend the next 5 minutes. Go ahead and try that. So hopefully you've got the things downloaded, installed, being Go, Docker. and that you've forked and cloned the Kubernetes repository. Oh, to back up a step, who here does not still have the slides links? Did everybody get the slides with the steps to go through for that? Okay, cool. So go ahead and spend a couple of minutes trying to do the things, try and get to where you can run make, and we'll float around for the next few minutes checking and grab us and ask questions, okay? While you're doing that, I will mention, so some of these things are not going to work or are going to take some time. So like the CLA, if you haven't signed it and we're done with the playground example, you will need to work through that eventually, but you could do that later in the future. Hopefully everybody who'd created a PR that had an issue with the CLA, I posted some information within there to help you get further along, but we can follow up later in the future on that as well. So I know people had felt it might have been a little cool in the room, but it's probably starting to warm up, especially right in front of you if you're trying the make command now. Yeah? All right. So it looks like most of you are succeeding. That's good. So I'm going to start talking a little bit more about what is going on in terms of what you're seeing happen. So we have multiple build systems. And that first make command is what I would call, I guess, like a local operating system type of a build, or a Golang build. When you run make, it is building the binaries for your local OS and architecture. So if you're on a Mac, if you look at your build output, some of the lines say Darwin/AMD 64. That's your sign that it's building for the Darwin kernel, Mac's kernel, and the x86, the 64-bit hardware. There's other commands that use a sort of parallel build system that are container-based. If you use those, you can build for other architectures and other OSs. Then the other thing that gives you is that it's more of a controlled system. In terms of DevOps, we like to have clean, reproducible builds, and if you're just building on your local laptop, artifacts of your local system could leak into the build. So the container-based one is a way of having certain prerequisites managed in a more consistent way, but it's also more resource intensive. So depending on what you're doing for a quick iterative dev environment, you may be cool with quick and dirty local builds, or you may want to go more towards the container-based ones. This morning there was a question about Bazel. Bazel is a very complex build system that allows you to manage these types of dependencies and reproducible builds in a lot of detail. I'm not going to talk about it here, but that stuff is there, and it's used by the project CI. Instead of using the make commands, you could also just do a go build if you wanted to. If you were in some directory, you could potentially, depending on the specifics, just run a go build there. The make files, make targets are the thing I think most of us will interact with day to day, and then Bazel builds are kind of next level. And there's a lot more information in the README linked on this slide. So let's talk a little bit more about the actual make targets themselves. So like I said, those are doing architecture specific, but the Kubernetes, I mentioned earlier, it doesn't run on Macs. Like the control plane doesn't run on a Mac, so somehow you've got to be able to make for all these other potential platforms that the project cares about. So when we do a make release, and I definitely say do not do this because it's going to make all the things. I've been on past release teams, and I work in SIG release, and there's a whole bunch of different platforms and OSs we support. So when you do that containerized build, you're getting not just the core binaries you get with a make, but the make release is going to build the client binaries, what are called the server control plane binaries, and the node-specific binaries, kubelet, for example, or kubeproxy. And it does that. It's not a one-to-one because some of these aren't applicable, like you don't have the server binaries on Mac, but it's going to make the applicable ones of those types of binaries for Windows, for Mac, for Linux. And it does it for x86, x86 64, ARM, ARM64, PowerPC 64, Little Indian, and S390X. So if you do a make release, your laptop is going to melt because it's going to try and do all of that stuff and massively parallelized, use every single resource for, I think, I did actually run this once, I think, successfully on my Mac, and it took like 4 hours or something like that. This isn't going to be part of your day-to-day thing, but it exists, and depending on what you all go on to work on, some portion of this client-server node, Windows, Mac, Linux, all the different hardware architectures, some portion of that's going to be relevant to you. Be aware that it's there, but you'll have to kind of find your path out onto that. Now, the other one that I want y'all to try, if possible, so if you do a make quick release, it's going to do, and you don't need to successfully make today or make quick release, but by running make and not having it error out in the first 10 seconds, that tells you your Go config is good. If you run a make quick release, and similarly it gets building and hasn't just trivially errored out, this is going to validate your Docker config. It's going to do a containerized build of those core binaries, and it's going to default to Linux 64-bit. So that's a useful one to at least try running so that you can validate that your Docker config is set up, and in the future, if you're needing to do that as your workflow, you know that your Docker stuff is set up right. And I think what I'm going to do is just briefly show both of those. How is my font? Are folks able to read? Okay. Okay. All right, so I am in my Go path. I'm in, as I'd mentioned, that cates.io subdirectory, and I've got Kubernetes checked out. I can look at my Git status. It's telling me things about my GitHub master, or I could fetch my upstream and Git rebase to upstream master, for example. And I'm doing this because I forget whether I did it this morning. And prior to like yesterday, building the master branch on Mac was broken. So I discovered this Friday as I was prepping for the workshop. I talked about our release cycle. We're halfway in between 1.14 and 1.15. You could argue that with a release cycle right at the release point is ideally the most stable time. Sure, ideal, CI/CD, you're always stable, but we're halfway in between release. So right now is probably the worst time for bugs being introduced versus being found as you stabilize towards release, and things are breaking. So sometimes you'll encounter this as a developer and you'll have to figure out whether master is broken for your particular context or not. Another thing that you might do, especially if you're in some sort of a support context or role, you might want to do something like a git checkout of a particular branch. So there are branches like the 1.14 release. I could check that out and do a build of that. And if I look, yeah, the latest commit on the 1.14 branch is also the thing that broke master for building on a Mac also broke the 1.14 branch, and then we found a whole bunch of other little things. So Macs come with really old tools, like a really old bash, and people have been introducing new bashisms into our bash scripts on master, and we have to keep catching those, and we could really use a unit test for this, by the way. Great first contribution maybe for somebody. So we keep breaking this and refixing it, and last week we discovered that we had merged one of the breaks into the 1.14 branch and had a whole set of fixes then that we cherry-picked back to that branch as well, but now I should be able to make in my Go config will build a local AMD 64 Kubernetes 1.14 branch. Slowly, maybe. For the purpose of time, I won't go ahead and run that. There's one other example I wanted to show. If you're, again, doing a particular sort of support stream, there's also a bunch of tags. So the 1.14.2 release came out last week. It's slightly older code than what's on the head of 1.14. And here, I know it's broken, so if I run this make, hopefully within a few seconds, whatever's going slowly, it will start. But but it'll kind of demonstrate that idea. Here we go. Yeah, this should fail in a moment. So there's various branches for the support of prior releases, and then all of these things are tagged as well, so you can check out particular points, and if you needed to do some development or debug relative to a particular thing, you could build and test in specific places. Okay, so we got Go builds, container builds, and let's move on to some make targets. So a plain make is maybe less interesting because you're building all sorts of things. Most of us in our work are going to focus more narrowly. Now, your particular role may be in some sort of DevOps release for a cluster where you're building all the things and rolling out a cluster. But if you're trying to make some particular change in a particular component, you don't want to build the world all the time. So there are these what targets. So you can make what equals and then some modifier, and it'll build just that. And that's obviously much less resource intensive. And this is actually oh, it's actually going. That one should have failed, I thought. Okay, anyway, so to move on to this. If I wanted kubectl only, I can make what equals command kubectl. And this should be relatively quick. It's gonna take a couple of minutes. Then I talked about how when you just run a make, it's running for your local target. So if you're on Linux, say you're on a 32-bit Linux and you run make, you're going to get 32-bit Linux binaries. If you need to build for some other particular platform that is supported by Golang and the project, you can specify a platform or multiple platforms on the command line by adding kube build platforms. So we went from make to make what specific thing, or you can add in kube build platforms. One architecture you could quote and have a space delimited set of targets that you are looking to build. And there's a whole bunch of other make targets. If you do a make help, it will give you information on them. All right, and so that built. So for everybody who's tried a make, did it take 20 minutes or something like that maybe, or more or less for that whole big make? Yeah? Is anybody's finished yet? They're still running? It takes a while, right? It definitely takes a while. So while I was talking about that one slide, my make what of kubectl for 64-bit Mac finished. Now, where does it go? Once you start building things, you have a directory called _output, and there's a bunch of stuff that goes in there depending on what all is happening. But for an example like this, for a kubectl, if I look in local bin, and it was building for Darwin, AMD 64, today is May 20th. And my kubectl binary is May 20th right now, 2:23 p.m. These other ones were last night, me double checking my commands and the slides, making sure they work. So you can see that stuff is there, stuff exists. And if I wanted to, I could run that one, for example. And what I like to show is that this is a very simple example, but hopefully it's representative of a normal development workflow. You need to build something, you need to run the thing that you're building, you need to know where the output was in order to run it. So, cool. But let's go one step further. Let's have you all try and build kubectl, but let's modify kubectl first, and let's prove that our modification actually worked. So what I want you to do is, I want you to edit the kubectl. Go back. I want you to edit the kubectl.go, and I talked about kubectl existing in command and packages subdirectories. We'll just do the command one, so we'll do a simple little printout there. So like add some type of a hello world printout like in the main function, and then build with the make what command. Do that ls of the output directory to see if you see the updated timestamp as you'd expect, and then run it and see if you see your output. So I like to run it, for this example, kubectl space version, it prints out version information on the kubectl client binary, and if there's a server that it's able to talk to that it's configured for, it'll print out server-side API information. So kubectl version just gives you a shorter output. If you give kubectl without any argument here, it prints out like a 2-page help message. So I'll just walk through this and give it a try yourselves. So I'm opening up command kubectl.go. And for people who aren't familiar with Go, I like to always localize this example. So I'm just coming into the main function, and I'm going to do a print line, and then I'm going to change my keyboard over to Spanish and remind myself of the Spanish keyboard. I want an upside down exclamation point, and I say, Hola, Barcelona. And then I have to switch back to the US keyboard where I know where the exclamation point is that's right side up. So Go supports Unicode and all sorts of fancy characters and stuff like that. So I save that. I'm going to make what kubectl. That'll take a minute or two. Should be a little faster now. Most of its dependencies and everything hopefully is in cache. All right, that only took like a minute. And if I look at my output local bin Darwin AMD64 kubectl, it had been showing 223, now it's 228, so it looks like it built. And if I try and execute that, first of all, the first thing it did was print out Hola Barcelona, so I know I'm running the thing that I built, and then it prints out normal version information. And since I had earlier, as an example, I checked out 114.2, and I've made a modification to it, the tooling is noticing that I'm on version 114.2-dirty of the code base. So if I filed a bug, for example, against this binary and I submitted it to the upstream project, and they say, well, that's weird, can you show me your kubectl version output? They're going to see that I've done something unusual here. So how about y'all? Who was able to build it? And is anybody struggling? Do you need some help? No, you okay? Anybody want some help? So again, I think this is a very contrived, simple example, but you could do this for any of the binaries, any of the components, whether command line or server side, and hopefully this gives you a basic representation of how, for a representative development workflow, you can make a modification, build within a very short amount of time, run and validate that the thing that's running is what you want it is behaving the way you want it to. Which is another way of saying you can do testing. Testing is a very big topic. There's 4 levels of testing I want to convey to you today. The first, most basic one is unit testing. And the way this happens for Kubernetes is just basic, simple, native Golang testing. You've got a file, you've got another file next to it that's _test.go. And that's it. You can make unit tests. Awesome, you should do that for code that you're adding. Definitely is something that you should do. If you're modifying some existing piece of code, you can also just quickly, iteratively dev test. If there's existing unit test coverage, you can just rerun the existing unit test coverage to ensure that you haven't broken something. That's only possible, though, on things that work in isolation. And Kubernetes is a distributed system. You have all sorts of components talking to each other over the network. So to test that type of thing, but still in a simple, somewhat mocked-up way, we have what are called integration tests. And those are to allow you to do some controlled interaction testing across packages or components. An example of that would be you have some code that interacts with etcd. You want to test it, you need an etcd running, and you need to run your code, some test case, and validate that it's truly able to interact with etcd in a way that you persisted something, or you pulled something out of it, or reacted to something that somebody else stored into etcd. The next most complicated level is end-to-end testing. And again, Kubernetes is a distributed system. You, at times, are going to need to test a full cluster and validate end-to-end workflows. Can I start up a container? Do the pods I declare get properly scheduled? Can I run a daemon set or different things like that on an actual cluster? If you're trying to validate overall behaviors and the functionality of a cluster, though, that means you need a cluster. And that can be complicated. A little bit later, I'll go through a few examples of ways that you can get at dealing with that. And then finally, the fourth level of test, and this is a relatively new thing. We used to always talk about just unit integration and testing. But as Kubernetes proliferates, and there are all sorts of vendors of Kubernetes, different distributions, all of us can customize and modify it, we need to make sure that Kubernetes as a thing still means something. So to do that, the architecture group is selecting and approving a growing set of tests out of that broader end-to-end suite. And they're called the Conformance test suite. And what this does is ensure that the core API behaviors of Kubernetes are a thing, that somebody doesn't sell you a Kubernetes that isn't actually a Kubernetes in terms of API compatibility. At this point, it's a relatively small subset, I feel like, and it's growing. And there's some complexity around this also because there are things that are Linux specific, but Windows container support, for example, is coming on. So we have to figure out how we update tests that were maybe written in a very Linux specific way to also be applicable to a Windows node, a worker node within a system. There's a link there, and I'll actually pull that up because this goes into a whole lot more detail. And this is actually the just sort of a jumping off point from the contributor guide. There's a brief paragraph on each of the types of tests, but for each of them, there's a link. So Go testing is kind of self-explanatory, I guess, but integration testing, there's a whole specific document that the community maintains, or in a repo of test code that talks about this stuff. And the same for end-to-end and conformance testing. And if I go also to the developer guide, within the developer guide, there's a testing.md. Oh, and it moved, tombstoned. It's under SIG testing now. This similarly has a whole lot of detail and links to additional information. So it's sort of a top-level landing page, but yeah, run all unit tests, cd Kubernetes, make test. Again, this is going to take a long time. You could add some timeouts, things like that to run specific things. Or again, with the make target, you could say make test what equals package kubelet and run just the test for kubelet. When you're doing some of the more complicated things like integration test or end-to-end test, there's a whole separate document. And each of those is, again, gobs of detail. But the etcd being an example of a basic place where you do integration testing, this doc would tell you how to go and set up a simple etcd installation and run a simple integration test. And then the same for the end-to-end tests. Okay, so let's actually try and do one. So again, for kubectl, we're going to go into for this one we want the package kubectl, because that's where all the code is. And if I look here, I see a few bits of test code. But in the idiomatic go way, I can say go test //. And since I'm down within the package kubectl directory, it's going to go and find and run all of those tests. So go ahead and try this. And depending on where you are within the code base or how much you're trying to do, this takes more or less time. If you call out a specific test, it could run quite quickly. All of them together, it's going to be a little bit more. But for something like kubectl, running its set of tests, I think takes a couple of minutes. So I'm starting to get normal Golang test case output and timings where these are taking a few seconds each. Yeah, and there it finished. That was pretty quick. And I could do the same thing also with or equivalent with a make test. What equals package kubectl? Oh yeah, for that it wants a dot in there, it looks like. The documentation says a doc, and it's actually suggested try putting a dot in there. There it goes. So it's telling me it's running tests without code coverage, but that's a useful hint that it's possible to run with code coverage. Again, this is basic Go tools. You can get code coverage, you can do benchmarking using all the native Go tools if you're familiar with those. So make test what package kubectl, it took 5 seconds and it gave me a thumbs up. Awesome. I would hope so, given that I only added a print line. It would be a bad sign if I was able to break something with just that. So were folks able to run those? Cool. All right. So this is the point where we get a little bit off into timing. So I was expecting a lot more trouble with development environment stuff, and I wasn't sure if we'd really get to unit tests and integration tests, but we're more or less on track to be able to try some of that. So let's give it a go. We'll try and run the etcd one. So what this will do is the hack install-etcd-sh is going to try to pull down an etcd container, run it with a known config that would match what a make test integration expects. So let's give that a try. All right, so that returned pretty quickly, and it says to use, export this path. Oh, and I thought this one was a container-based one, but it may not be. So I'm putting that in my path, and now I'm going to do a make test integration, and let's see what happens. All right, so we see it says it started an etcd instance. It's showing the network location of it, what it's using for a data directory, and now it's starting to run integration tests. And it looks like it's working. Looking at the download, so this one, it wasn't containerized. It just went out to the web, found the etcd binary that matched my OS and hardware architecture, and that binary is trivially runnable with a config without a bunch of other dependencies. As you get into other more complex interactions, perhaps you might have much more complex things that you have to self-manage in this regard. I'll put that back. So this is where the hack commands, I feel like that's kind of a misnomer, because this might be a normal interaction where if you're writing code that writes to and from or reads and writes etcd, you quite frequently might need an etcd instance. So you're not necessarily hacking, you're just doing normal development workflow. So it's not like special stuff. There's normal developer stuff in there. It doesn't need to be intimidating. And my fan is going crazy, so I know that it's doing something. Is that working for folks? Is doing something anyway? Yeah? Yeah, so well, let me actually go back to, or I'm going to pull up Julia Evans Kubernetes. So Julia Evans has this awesome blog that's like graphical stuff. Oh, and I think this is the one that I want. Oh, you can't hardly read it. So in that architectural diagram, I showed kind of the control plane, and there's like the cloud that whatever platform is underneath your control plane, and then there's the worker nodes. As a human, you interact with the control plane with kubectl. So kubectl, you hand some YAML over to the API server, and the API server says, cool, awesome, I'm going to store that information. It writes it into etcd. You make a pod spec. Similarly, it's going to validate, write it into etcd. But when you want to run something, kubectl says, here's a pod. API server says, okay. And it stores the pod definition in the API server, or from the API server takes that, stores it in etcd. And the way these cluster components interact is it's a declarative system, and each of the components is watching and monitoring, and when it notices a change in the declared state, the components try to move the state forward, right? So the scheduler, in this case, somebody's defined a pod, the API server's written it in etcd, scheduler's watching etcd, and it sees there's a pod there and goes, oh my god, I haven't got this pod running somewhere. So the scheduler says, I need to figure out where to put this. And it decides, I'm going to put this pod on machine X. So the scheduler writes machine X into, or messages it back to the API server. That gets stored into etcd. So now in etcd, there's a thing saying, hey, there's supposed to be this pod running on machine X. Machine X has the kubelet component running there, watching etcd, and it says, oh my god, I'm supposed to be running this pod, but I'm not. So my state does not match the declared state. I need to start it running. So that's sort of how the end-to-end flow happens here. This particular test case is running a variety of things where it looks to see, can things write to etcd correctly? Can they read to etcd correctly? Since it's sort of, there's not like a point-to-point networking protocol where I say, hey, you start this thing. It's all happening via etcd, so this becomes a key integration point for the cluster control plane to have coherency. Does that help answer the question? Yeah, yep. I should have explained that a little better, yeah. All right, so that's running. I forget how long this one runs, but just as an example. And for a variety of these sorts of things, as you're reading through the documentation, you'll see some bit of a helper script like this often, because it's such a common thing where you need to spin up a something, there's often a script in the hack directory that's helping with that, and then a make target that corresponds to doing some validation there. So I'm going to just kill that and go on to the next one. And this one, I need to kill a number of things. So end-to-end testing, that's about testing cluster interactions. If you're going to test actual interactions across a running cluster, you need a cluster. So there's some helper scripts that allow you to make a cluster. But because the control plane is, the worker nodes are presumed generally to be Linux, or now starting to be Windows, you need that right platform. So I can't just run a cluster so easily on my laptop. So what I'm going to do, and I just killed Docker because Docker uses resources. I'm going to fire up a Linux machine and run through an example of this cluster bring up and end-to-end test start. And this is, hopefully I can go through this example in maybe about 10 minutes. The test won't be running, but we can get it started. So it shows what it might take for you to do this. And it's actually important to do. So it's a normal thing where you see a bug and you want to fix it, but none of us are experts in Kubernetes. It's like impossible to be an expert anymore in Kubernetes. And you shouldn't just rely on your own expertise. So you make a change, and if you're responding to a failed test, then you should run that test. And quite often, the tests that we notice that are failing are end-to-end tests, because that's what the CI system runs automatically on our behalf. So it's a pretty normal workflow to at least have some specific end-to-end tests that you're wanting to run. And all of my building has just like totally cratered my machine. Oh, and I was also talking about resources and things. I should show, I feel like on average, I do a lot of my development in this Linux virtual machine, and what did I say I had? So I've given it 12 gigs of RAM and 8 processor cores. So I've given it a large portion of my Mac. But I'm usually either sitting in the VM just doing stuff there, or out in Mac by itself. And it usually works okay as a workflow. Say, yeah, so I have issues running Homebrew. Like if you have an IT managed laptop, for example, you might not be able to brew install all the new bits, which means that you're stuck with a really old Git, a really old Bash, really old everything that you might do. So I use Vim as my IDE. So if it's more than a simple Vim or a Go build, I move over to my Linux machine. If it's something where I need to run an end-to-end test that I want to run locally, I move over to the Linux machine so I can do the local cluster up. Wow, this is like beyond slow. Maybe I won't be able to demo this. I had the VM running earlier, and I had everything all up and warmed up, so I'd just be able to flip over and demo it. And then I accidentally had a make running in Mac and a make quick release running in Linux, and like I thrashed the machine completely. So now it's having to reload everything from disk or something. All right, well, I will just... I killed Docker intentionally. But it may be dying still. I mean, this little icon went away. I don't know. Let me just check. What does it say I'm doing? The main thing running is just the virtual machine. Did it actually come up but not come up? Nope, it's not there yet. That is. I'm just going to kill that and restart it because it seems confused. Okay, so did I answer the question on when I choose to use Linux versus Mac sufficiently? Yeah, I think the lines are it's gonna vary a lot from person to person. And then this is all, so I wanted to leave you with just an initial pass of how to do things locally on your laptop. But for a lot of people, if you get off into your job, you may have some test pipeline where you can place code and it will spin up clusters for you and run tests or things like that. Your specific work environment could really determine what your ultimate workflow looks like. Or if you're very much focused on AWS or vSphere or GCE, whatever the platform is, it's all gonna vary quite a bit. Well, I do not know what my VM did here. That's unhappy. Well, I guess rather than demo it myself, who has a Linux machine available? I guess I'll leave this up, or you've got the slides, you could try and work through it yourself. For the people who haven't, I guess I probably should just move on then so we can keep talking about some things. So conformance is similar. Oh, and well, I'll at least I'll speak to this. So there is a thing called local cluster up in the hack directory, and it requires sudo because you're basically setting up a cluster and control plane components that are going to require root privilege for running. But you run that script, and it's actually a pretty informative script. The test output, it describes what it's setting up, and then it tells you that it's created a kube config for you. And literally will give you some copy-paste stuff so that you can set up your kube config environment variable to map to the one that it created for you, and it tells you where the cluster is, and it actually just, that shell stops running but doesn't exit. So at the point that you want to kill the cluster, you can just Control-C that. Otherwise, in another shell, you open up, export the kube config, and then run the kubetest program. So kubetest with a provider local, it can also be something remote if you're wanting to test in a cloud, but with provider local, it understands to look for this local cluster, and then you can tell it some optional arguments around how many pods and things it should run, and maybe a particular test focus. So I just pulled up a secrets-related test case just to have one limited test case. Otherwise, I think by default, if you don't tell it anything, I think it runs them all, which would obviously be like a huge amount. Yeah, that's. I wonder. I want to actually try, and since we have time, I want to try and make this run. Oh, the other thing that I have that's using gigabytes of memory is Slack. Let's close that. So there is a problem with Fedora and VMware Fusion Desktop that's a known problem that looks like that, but I haven't had that problem like even just this morning. So let's see. Oh, I think my Mac is actually confused. Let's see. It may have been. Maybe that one. Which one? Is there one? Yeah, that one's not wanting to kill, so I don't know. I've had virtualization-y things end up killing the kernel and need to reboot on a few occasions. I was not wanting to do that today. Yeah, it didn't actually close because it still says that thing is running. It's unhappy. Well, I guess I will go on then. So if you've done the same sort of thing for the end-to-end testing, then you've done this local cluster up, or you have a remote cluster somewhere, you can do then the conformance testing, because those are a subset of the end-to-end tests. So you do the same sort of local cluster up, but then if you've run some particular, you've built some particular thing and you run kube test and you give it the focus of conformance as a string, and it's going to run the conformance test and let you know. The other option that you have with conformance is Sonobui. Let me just go over to that, Sonobui, and I always misspell it. So Sonobui is a tool that Heptio created that basically does the conformance testing in both a non-destructive way, but it allows you, where the example that I have in the slides is using kube test and sort of more local oriented, where you've made a code change and you want to validate that you didn't break something hypothetically in Kubernetes. What Sonobui gives you is the ability on a running cluster to validate that that cluster, as it's been stood up, is actually still conformant. So kube test and the stuff in the slides lets you see that you haven't broken Kubernetes in the abstract. Sonobui you could use for that purpose as well, in as much as you run it on a cluster, but you can also, it's a little more powerful, you could run it to validate that a cluster that you've stood up, say you run a cluster, you manage a cluster in production, that as you've implemented it, you haven't somehow broken your cluster, or if a vendor's given you a cluster that you haven't done that cluster, you haven't received a cluster that's not conformant with Kubernetes. So there's a variety of conformance enabling tools out there. And it's really important, I think, going back to the discussion about how to do open source, is this idea that, like we did in here on a couple of occasions for the playground example or the Kubernetes repository, you all forked the project. And it used to be that projects would say, like, fork it on GitHub. There's like a little banner on web pages. And forking is really, really easy in open source, but unforking is hard. And it's important as a project, as a core, that we represent something, that we don't become completely fractured as all of these forks are created, as a normal part of development. So a conformance test is a way for us to ensure that as we all do divergent activities for whatever reasons, that we still bring it back to the core in a fully open source way, and that we're working together on a shared end goal, Kubernetes. We've got two other ways that are common for testing when you need a cluster. So this local kube up, if you've got Linux, it'll get something running sort of ephemerally on your test machine. The other one that's been very popular for a number of years is called Minikube. And basically, it's a fairly easy, lightweight way to run a cluster in a virtual machine. So on your laptop, for example. Again, like I just demonstrated as an example, where I had trouble, I've somehow messed up my laptop at the moment, but my virtual machine didn't want to run, and between the virtual machine and Docker and just the build itself and all of those resources, they're potentially conflicting. And this is yet another thing that wants to run yet another VM. And it's going to be something potentially large because you're trying to put a whole cluster in it. The other trick that you have to consider is where that one on Linux is just doing it all right there on Linux. You don't have any networking issues really to deal with. Once you run in a VM where you're doing your dev on the host and you're running that guest, the cluster in there, you have networking and internet connectivity issues that can be slightly problematic for you, and you have to kind of become a network admin on your own machine. So that could be a hurdle. But for a lot of people, this is a useful tool and it's quite popular. And the only gotcha there is that it really depends on how you plumb it. It supports all sorts of different hypervisors, and there's lots of different glue that you can set up to do things, and you get a huge interoperability matrix problem of which way did you set up your hypervisor versus this and that. And that can be complex, especially as you start out. So increasingly, like Minikube is quite popular. It's been around for a number of years. It's an active project. It's well maintained. Over the last year-ish, this tool called Kind has become increasingly popular. And this will run a cluster for you in a container on your local machine. So for this one, for example, it does support running on Mac, as long as Mac is working. So like this was also broken earlier in the week because building on Mac wasn't working. So this one has a little bit lighter resources needed, where Minikube, you've got your host machine's got to have your kubectl, you've got to have a guest VM, you've got to have connectivity to the guest VM, and all of that is sort of sysadmin, network admin work that you have to do. Kind, basically, you just need Docker. And you'll need your Go stuff as well, but that's all stuff that we've just validated is there. You need internet connectivity, but that's only, I think, initially on a first container pull. So subsequent, if nothing's changed, you can just use the local container image. So this one, I want you all to try, actually. This one's fairly lightweight. The cluster up, it would have been nice to do too for the people that had it, and I wanted to demonstrate it and then show sort of side by side, but we can all do this one. So the first thing is, you want to get a copy of the repo. So you'd want to do a git clone of that. I'm going to pull up a terminal. All right, is that big? Yeah, that should be okay. All right, so I have that already sitting in here. I'm just gonna make sure I have set up. Okay, yeah. I'm just gonna make sure that I am up to date. I haven't forked this one. Okay, so I'm good. I stick that right in between. So yeah, okay. So you got the URL there if you want to git pull that. Maybe if I don't make it too small. I guess we can do that. All right, so you start out with a go get, and that's going to fetch things that are related to the Go dependencies around it in addition to getting it itself. So there's a little bit of network traffic here, but not too much. And I'd actually already done this, so I could have skipped it. Again, like once you have this seeded in your system, you don't have to do this every time, but y'all would want to do this. You can either clone the repo or go get it either way. Actually, you only need to clone it if you're actually going to do stuff with the code. So without it, you can just go get, and it pulls the stuff down into your Go directory alone. So yeah, just let me make this bigger because this is all you want. Yeah, the set of stuff at the bottom there. And this is all, that's why I put the URL there. The URL, if you go to the URL, you can copy paste all of these commands that are in the slides. So that was why the URL was there, not to fork it, but to get the command. So pull that up in a web browser. You can copy paste the commands. There's the go get, which that took only a minute or two. And then if I do a kind, there's two things you can do. I could just start a cluster, but kind is also useful for dev test, and it understands that if you have your Kubernetes repository checked out in a particular place, it can build your code. So like I had done that example before, and I had checked out Kubernetes version 1.14.2, and since I'd modified it, it showed 1.14.2-dirty. If I do a kind build node image, it's going to, it should, why did it not do that? My go get must not have worked. Go get inconsistent versions. So my go get failed, and I didn't see the output actually. And it's not printing out the reason. I'm guessing it's trying to get something from one of the dependencies, and it's failing at fetching it properly. Well, that's a bummer. So I'm going to model open source involvement here. I'm opening up Slack, and I know that the guy who leads development on this, I saw him eating lunch out there a few moments ago. So I'm going to say, Ben, are you online? He's got a green dot next to its name. So lightweight bug report. And then I wait and see what happens. Does he come back quickly or not? Hard to say what he's doing today, right now, out there. This is probably the trade-off between kind and Minikube. This is the first time I've hit something like this, but I've had other people, oh, and there he is. I noticed that's big enough quite to see. So that he's surprised is a surprising sign. So Minikube has been around for a while. It's well supported. It generally works. Kind is much newer. So he wants to know version. Oh yeah, this is a good point. So in addition to doing that, so with the repo there, if in the readmes, one of the things that it mentions is you can get the binary. And I didn't want to do this because again, sort of like talking philosophically, I have a problem downloading and running things from the internet. But I will do that as an example. That's another bug. He makes sure that the stuff works on Mac, but he gives a command line that requires wget. Anybody off the top of their head know the curl follow redirects command line flag? L? No. Why do I not remember that? Oh, capital L. There we are, redirected. Okay, so I have a kind binary. I can So if you fudge your Go dependency tree, it might work. All right, so now, I downloaded their binary, I put it in my tilde bin. Why did it not work? Oh, look at that. All right, I hacked a kind into my path. Kind exists. Go back to the slides. When I do this kind build node image, it is going to set up kind based on the state of my Kubernetes repository. Ooh. And I put that in that shell, but I need that shell. All right. Error finding kuberoot, could not find. So my shell is all confused right now. Maybe I ran this in Linux the other day. I swear I tested all of this. What is he? I thought he said he wanted it somewhere in just the standard place. Node image. Build a node image and create a cluster with kind build node image. It needs cloned into this directory. My Go path and source Kate's Kubernetes. I'm pretty sure that's where it is. Yeah. Well, that's weird. So, as I was saying, Minikube, well supported, been around for a long time. Kind is really interesting when it works. Like I did this the other day to validate, and it was like, I know it's new. I've heard some complaints at times about it not working, and it works so flawlessly that I really wanted to leave you all with it today as a potentially interesting option, but I'm not giving the best impression of it. Huh. Yeah, I'm doing exactly what the README says, and this exactly worked the other day. Did it? Okay, well, perfect. So try this. And instead of trying to figure out what happened to my laptop, why don't you all go to the kind location. You can either do the simple steps there for kind create cluster, which will just do a basic setup with Docker. Oh, when I went over to my VM, I killed Docker. This probably makes a difference. So as soon as Docker starts, I'm just going to go the easy path, kind create cluster. So the idea with kind, it's trying to get all of the control plane and components set up within a container. So you have a Docker container, you have the impression of nodes and control plane units and all of that, and you can have a simplistic cluster, and you can run kubectl against it. You have all of your components interacting, and you can do the basic sorts of things that you might need to or want to do as a local developer. All right, that's running. So kind create cluster, it's grabbing a container image. Oh, and this is where the slide that has the Docker pulls, if you do those, they should come from the little machine here instead of from the cloud. And I'm kind of confused why it's saying this right now for me, because I had all of these images pre-prepared, so I didn't need to use the network really at all. It's actually pulling a much older image, which is strange. Well, give this a go. We'll spend like maybe 15 minutes. Let's see if you all, especially the folks on Mac, if you can get this up and running on Mac, and then on Linux it's also viable. So let's everybody try this. So go to the Kubernetes SIGs kind or repo, and then go through the README there for the basic. And your goal is to do a kind cluster create. And then once it's up and running, do like some kubectl commands, interact with it, and see that you see it. So my thing finished getting the image, and it says it's preparing nodes. Something else that you see here, creating kubeadm config. So is the project, the Kubernetes project is moving towards more consistent ways of managing clusters. There's a new tool called kubeadm, or a newer tool called kubeadm, which is making a more standardized way of administering, maintaining, upgrading clusters. So kind actually uses kubeadm to roll out its internal cluster. So kind is using, sort of dogfooding-wise, the kubeadm tool to manage the cluster that's in this container. It says it's starting the control plane, and this was actually relatively quick. The cluster up, if my VM was working, would have been similar probably. So as with any of these methods, you have to understand where your cluster is. So the tool creates something for a kube config for you, and if you specify and execute that, then you can run kubectl commands. So just as a silly example, I'm gonna go with that one that I just built, that output local bin Darwin AMD 64 kubectl. Instead of my system kubectl, I'm gonna dog food the one that I just did, right? So I'm gonna say kubectl cluster info. So first of all, what I want to see, kubectl should print out my little printf, right? But then it's also going to go out to this live cluster. So you get the Hola Barcelona, and then it goes out and talks to the kind cluster that's running here locally, and it sees stuff. So if I kubectl get pods, nothing's running, obviously, right? But I've got a cluster. So I'm going to walk around and see if you all get clusters up, and you all could maybe try and start something if you wanted to as well. For kind. Okay, so somebody just figured out for kind you can make build, and that appears to do it in a dependency managed container, and things just work. Something screwy is going on. So similarly, running just a kubectl, which is coming from a different binary in my path, but kubectl version, I've got a 1.14.1 version there, and the server that it's talking to, that kind set up, it shows 1.13.4. If I do my special built kubectl version, I get that 1.14.2 dirty client version. I see my printout, and then again, the server version is coming from the actual kind server. All right, it seems like for the most part, people are making some progress. I'd encourage you to keep an eye out for Kind. It's a pretty nifty little tool, and when it's working, people are really excited about how simple it makes some workflows. And it's open source. The developer, he is an awesome guy, super friendly, super helpful. I see this project as a really, one to definitely keep your eye on and give a try. DIND? I am not super familiar with that. So for a while, people were doing Docker in Docker sorts of things, and I know the acronym, but in terms of that as a development tool, I hadn't personally used or seen a lot of usage on versus Minikube.
Yeah, I found it quite useful because there was issues. I use usually Ubuntu and there was issues on that, and I talked to one of the guys on Minikube, they said, yeah, they had issues with it. So when I first started, I moved over to the IND cluster, and I found that far more stable than the usual.
Yeah, the general comment I think is, so there have been a variety of tools, and I've wanted to make sure that you all get a sense of there being a variety of tools. Your mileage may vary with each of them depending on your specific use case, and they're all in development and open source and in different states of progressing along. Kind has gotten a fair amount of momentum in just the last little while. And I think one of its big benefits is that compared to a lot of the other ways of running where you have duplicated resources or a lot of overcommitment of resources on your laptop, that it's just, you don't have this inception of all of these layers. Like I wanted to, because I was afraid some of you were going to be using Windows and I wanted to check and see if I could describe how to do this on Windows, I was going to run a VM running Windows, running Docker for Windows, which also runs in a VM, and then run the cluster in Docker. But like I've gotten so many layers up the stack that with Kind, you just have one layer. Whether you're on Linux or Windows or Mac, if you've got Docker running, and the Docker stuff is fairly well stable and supported, there's just the one layer, and it's not so many variables there. So we've got a half hour to go. And I want to circle back to talking about, and definitely keep fiddling with this on your laptops, playing around, and not just today. I mean, obviously in the future. This is all just to, I feel like I'm not so much teaching you to fish. I'm definitely not handing you a fish, but I'm trying to describe the concept of fishing. That's kind of where I hope you leave with in terms of this Kubernetes development sort of stuff, that you know enough to like start going into the next level and start actually practicing it yourself. But to that end, like, what's next for you? So I want to talk a little bit more about SIGs again and engaging. We've talked today a whole bunch focused on code, but early on I asked because I wanted to understand, like, are you here from the coding perspective? And not everybody is always. And I feel like sometimes we even turn some people off by focusing on just the code, but it also echoing kind of the earlier sentiment on being a better engineer. There's also lots of opportunity to engage in non-code areas. So that newcomer who joins the project and runs into problems, like an issue with Kind, for example, or trying to figure out what's going on there, do a little bit of debugging, file an issue, and that is a super valuable contribution. but especially as a newcomer, you are all going to see all sorts of things that a lot of us don't see because we've gotten so used to working around it in our normal day-to-day thing. So as you see room for improvement, contribute to the improvement, or at least kind of have a conversation, maybe open an issue about areas where improvements are needed. All of these interactions aren't super scalable. Like I just happened to ping Ben, the guy who wrote and maintained Kind, or the lead developer on it. I ping him on Slack, but all of those one-on-one interactions aren't completely stable, and we need more people who are present, whether on Slack or things like Stack Overflow and the discuss. As you learn things, share your learnings. We definitely need more people doing that. There's a ton of other things. GitHub repo management, all of those repositories and all of the bots managing it, who has access to write and which areas. There's a huge task of creating automation around that and doing ongoing moderation and updating of who's who, what's what. Our marketing people who had been here, they're trying to understand more about the project so that they can do their marketing job relative to it. Anytime you learn something, blog about it, that's awesome for the project. Events like this, we need more people to get up on these stages and do this type of volunteering and all of the background stuff that happens into getting here to run an event like this. But it also doesn't have to be Kubecon. As you learn stuff, when you go back home, look and see what meetups you have in your local area. I know my hometown, the folks who run the local meetups are constantly looking for people who've got some knowledge about something. Like it's wide open. If you know something about something, hey, cool, come speak about it. So as you learn something about Kubernetes, go share those learnings with people. If you really like Kind, it's an up-and-coming thing, you figure out how to use it, do a little talk at a meetup on Kind, share it with others. We need artists and all sorts of things around visual communication, and the list goes on and on and on. So keep those on the back of your mind as well. Don't just focus in on the code. Think about other broader contributions that you could do as well. As you go through your Kubernetes contribution experience, you're probably going to find times where you need more information. I'm still learning about Kubernetes. I expect at this point that I almost always will be. It's just so huge and it's moving so fast. So we have a lot of ongoing things that we do as a community. Meet our contributors. Is it monthly, Jonas, or more? And there's a European friendly and US friendly. So there's kind of the calendar that Gwen had showed. There's all sorts of SIG meetings, but there's also some kind of bigger top-level things in there, like Meet Our Contributors, where a couple people just get on and there's a live stream on YouTube and they're talking about whatever it is that they know about. So that's a good opportunity to get some breadth of exposure to things. There are some group mentoring initiatives, and I think on that one, where are my speaker notes? Oh, I didn't link it. Oh, it's on the next slide, that's why. So there's group mentoring things going on, mentoring initiatives. The release team. So I work on SIG release, and our goal is to make reliable quality releases 4 times a year. And each one of those releases has a team of people doing the work. So I was on the 110 release team, so I got this t-shirt. There is a release shadow who just walked in the door from the past. There's a bunch of people who have gotten into Kubernetes partly by shadowing a release team role and starting to learn about something on the release team, or they've enhanced their contributions or broadened their knowledge. And I feel like the release team is a particularly interesting place to do this because it touches on everything. On any given day, the test infrastructure might be broken. Every day there's test cases that are failing. There's something unusual going on around the branching and the movement of patches. There's people who have to track what incoming enhancements we have and then the ongoing health of those, and then prepare blog posts and marketing, and like that whole spectrum of non-code things additionally lives within the release team, so that at the point that we make a release, the last week of June, 115 coming up, that you'll see PR out there, and it's actually informed and correctly reflects what's in the code. We have some one-on-one ad hoc mentoring going on, and there's a portion of this that'll be happening on Thursday. Has anybody here signed up for the speed networking mentoring session on Thursday? No? At the Kubecons, we have these things. It's hidden kind of in the whole schedule, but there's a sign up. We have a room sort of like this where we have a bunch of mentors and a bunch of people who have questions on open source involvement, careers, or technology specifics within Kubernetes. And we try to get it so it can be one-on-one, and we'll sort of have everybody spread out in the room and chat, ask a few questions, and every 5 or 10, 15 minutes, we switch everybody around the room. So it's like an hour or so of time where you can just go learn something. And we have all sorts of experts there. We have the Google Summer of Code and Outreachy as well, if those are things that you qualify for. And these are all linked out on the Kubernetes web, and you could Google for any of these topics and find additional info. There are a ton of tutorials out there as well. I think especially as you're doing code development, the tutorials can be useful where somebody's described a high-level goal and you get to read that and maybe kind of can relate to it. Like say, for example, if you're needing to make a controller or do something with a CRD, go find the tutorial on that where somebody's made a dummy mock-up of one and you can read through it, and it can be the framework potentially that enables you to, is your jumping off point for the one that you're writing. So links, again, you've got the slides, you can refer to all of these, but all those mentoring sorts of initiatives, meet our contributors. A number of the SIGs have office hours where you can just show up. It's not like it's a SIG meeting where there's a development agenda where we're trying to drive consensus on how to do this feature. It's just an office hour. Some of the leadership and core contributors are there. You can show up and just ask a question. And then finally, the contributor guide and the developer guide. So both of these have been under fairly active editing, re-editing, curation. We're trying to really level that up. It's still, I feel like, it's vastly improved compared to a year or so ago, but it's still a big need. And again, this is an area where as a new contributor, these might be some of your first contributions to documentation, is you try to figure out something. If you think this is an obvious thing, like why isn't it documented? Make the document. It's a simple PR, and we love to get PRs like that on both of these guides. The contributor guide is sort of like, how do I get up and running? The developer guide is trying to be a little bit more nitty-gritty details on specific areas. So like if you're trying to figure out how to do some specific thing, it might be off in the dev guide instead of the contributor guide. So useful links to refer back to later. And then all of this you can do this week. I mean, the conference has all sorts of talks that were, somebody had something that they were doing, they wrote an abstract and proposed to talk about it, and I don't know how many thousands of talks. I think for the track that I reviewed papers for, like, there was a huge number and a tiny got selected. But there's tons of content out there that you can just kind of go and explore. Beyond just those talks, though, where somebody's done some innovation that they want to share, each of the SIGs had the opportunity to do an intro and a deep dive session. And I don't know that all of them have done either or both, but most of them have some representation there. So if you see the SIG intros and deep dives, if you're curious about networking, or you know you're going to be working in networking, go check out the SIG networking intro and or the deep dive and see who's there. Some of the key players of the SIG most likely will be there. They'll be talking about what their SIG does, where they're headed, and it's a great first place to get an orientation. I also like those because I don't have time to be involved in all the SIGs I'd like to be involved in. So I'll go to some of those talks just to get my sort of once or twice yearly update on what they're up to. And then the hallway track. There are going to be all sorts of awesome conversations that happen in the hall. If you see somebody on their badge who it's a name that you've seen somewhere in the project that you're interested, you've had a question on, feel free to, well, look and see if they have their stickers that say like yes approach me or talk to me or whatever, and be respectful of that, like from a code of conduct perspective. But I think most of those leader sort of people understand that part of being a leader is being out there and being open to conversation. And they expect to get stopped by all the people that they know, current contributors, and also new people who have new questions. And it's also totally fair to just say like, hey, I'm Tim, I just did the new contributor workshop, I'm really interested in SIG networking, I'll be trying to show up if you see me on Slack. It's just, hi, I'm Tim, just wanted to say hi. Be people, be friendly, and I think you'll find that people are here in this project are people as well and friendly. You may also be walking around and see like a big cluster of people talking. We've tried to encourage people to follow the Pac-Man rule. I don't know if you've heard of this. So like, you know the shape of Pac-Man? It's not like a closed circle, it's sort of open. When you're standing in a conversation circle, like leave the circle open, room for somebody else to join in. And if you see a circle that's open and it sounds like something interesting, feel free to just kind of poke in and lurk and see what they're talking about. This conference isn't just people presenting, it's not just people down on the expo floor selling, it's about collaboration. And that collaboration happens through these types of conversations. Help wanted. So GitHub has kind of standardized on these two labels, good first issue and help wanted, and we use those in this project as well. So as you're looking on areas to get engaged, go look. Actually, why don't I just do this? So in the Kubernetes Git, and if you do git.kates.io, it's a shorter way to get here typing-wise. But at an organization level, you can search for issues, and you can do it by, you can add things like a label. If you can type. Oh, and I did. I need that. Label help wanted. Oh, and this is doing much too specific. Open issues with a help wanted label. Oh, and I inadvertently searched for all of everything on GitHub. What I wanted was, I think, is it org Kubernetes? There we go. 399 open issues right now where the community is saying, we would like help. You can do the same with the good first issue. So help wanted could be like backlog stuff, and it may be something wildly ambitious. Like if you go back a year or two, IPv6 support was getting added for networking. It was done on the side, and dual stack support was left for the future. I don't know if they literally put help wanted on that, but you could have that sort of level where it's a big, complex technical thing, but hey, if there's somebody who's a skilled engineer ready to do that comes along, cool. If you do good first issue, these are ones that have been curated where somebody believes that this is definitely applicable to somebody who's newer. So you can all self-level. I'm not going to presume that you're all newbies and you all need trivial stuff. Figure out which ones. And then within that too, if you pick one, and you read it and you find like, hey, I don't get it, feel empowered to leave a comment and say, hey, I'm new, I'm possibly interested in this, can you explain it a little more? I'm unclear on this or that. And even if it doesn't end up being the issue for you, you asking that question and getting the answer makes it more clear for the next person to come along. So that's just helping collaboration that much more. So 107 open good first issues across the organization. And we try on a SIG basis as we're triaging and scrubbing our bugs and issues to periodically make sure that we also look to see, hey, some of these things that are sitting here that we haven't done, let's flag those as help wanted. Let's triage the help wanted to make sure that some of them that could be good first issues are marked as that, so it's accessible as people come and try to discover it. Oh, yes, very good point. Yes. So we went through the playground. So the question is, what's the etiquette for this? So we went through the playground, and we didn't do that as an example, but you all saw, I think, the conflict. Like, somebody noticed the README said Seattle instead of Barcelona, and a bunch of people said, hey, here's the fix. Now, in a case like that, the overhead of creating an issue, claiming the issue, only accepting the PR from the person who did the issue, that's not going to happen. But those types of things exist in a broad community, and we don't want anybody to waste their time doing redundant things or conflicting things. So it's totally cool to append a note, and as a non-member of the org, we can't assign the issue to you. You can only assign to somebody who's a member. And I think that answers the question about the assignment. You should be able to assign to somebody as a non-member, I thought, but the receiver of the issue to own it has to be a member. As a non-member, the issue wouldn't be assignable to you, but if you just leave a comment saying, hey, I'm new, I'm a non-member, I'm looking at doing this for my first issue, or my first PR, generally I would expect the community to respect that and give you the space to do it. If it's been sitting there for 6 months and there's no other comment, yeah, somebody might post and say, hey, can I take this up, or something like that. But also then, if you take it on and it's going to take a bit of time, maybe give a periodic update. If you've pushed some work in progress commits that you aren't ready to PR, you could also maybe reference them from there, just to give some cookie crumbs to show that there's activity and stuff is happening there. Very good question. And that's kind of goes back to that open source best practice of being communicative, transparent, and responding to people and just putting it out there. I've seen a couple issues where on some projects people are tentative to open an issue. Like, so you're a new contributor, you see a little bug, and you think, well, I should be a contributor, I should open an issue. But you also think, oh, I want to solve this. If I open the issue, maybe somebody else will take it. Go ahead and open the issue for visibility and say, I'm working on this. I hope to have a PR in a bit. And people should respect that. And it kind of gives a track record again. People see the persistent record on Git where you raised an issue, but then you went the next step. You solved the issue. And people really value that. So at 4 o'clock, we're going to have a bit of a break as well. But I wanted to give you all just a few minutes to kind of chat with each other and just kind of vocalize a bit what you're thinking about being for contributions, where you're interested in, and just kind of chat a little bit about that here. And then when we have the other folks come in from the SIGs for the SIG meet and greet, and the folks from the 201 class, that maybe you're a little more, and I don't want to say nervous or presume anything, but like it's sometimes it takes a little while to formulate the idea. And if you've got a few minutes with one of these SIG leads, you want to maximize your time. So kind of use the time right now to kind of think a little bit about what you might want to chat with them about and talk it over at your tables. And I was really impressed in the morning when Gwen did the other part of this exercise to talk about talk amongst yourself about what you might contribute. There was a total buzz in the room. So I know you guys aren't shy. I know you all aren't shy.